Uh,
Loading.
Good evening for David. Yeah, David's time only 1 hour different from us, right? Yeah, nice to meet you, all of you.
Okay, maybe we will wait for 1 more minute, and then after that we will start this guest lecture. Sorry for waiting.
Laudi, can I start sharing my screen?
Okay. Wait. Okay. You want to start right now? Okay, let me
No.
open first this guest lecture, Theo. Thank you. Welcome all of the audience to Department of Accounting guest lecture series number 8. And today's topic is how to implement a data analytics and emerging technologies enable accounting curriculum. I think this topic is very important for us, especially in Indonesia, because we just have adopted these data analytics things in here. I think, but in United States, maybe more advanced. That's why we need to have some this topic important for us to learn from you all. And then our outstanding speaker today will be Professor Theo Stratopoulos from University of Waterloo, Canada. And also here there is a Professor Dwayne Kennedy. I think you put together this article, right? Co-authors for this.
Correct.
This great article. Okay. Before that, I will share and show you the curriculum vitae of Professor Theo. And here. Theo's teaching and research focus is on data analytics and emerging technology. He earned his Ph.D. at University of New Hampshire. And Theo has authored numerous articles and open source texts on data analytics and blockchains. He is a member of the CPA Canada Audit Data Analytics Committee and also senior editor for the Journal of Information System. This is from AAA, right, if I'm not mistaken, this journal. And also here are the current publication from him. And Theo also was awarded the recipient of the Research Fellowship Award in 2012 and 2013. He is also the recipient of the Best Paper Award, the role of IT executives on the firm's ability to achieve competitive advantage through IT capability. And then here are the ground rules for this guest lecture today. The guest lecture is being recorded and live streamed. And please stay muted until called upon and turn on camera and use Zoom virtual background that has been shared. And also please rename the Zoom account in the format of name and also your institution name. And then for the last session, we will have a question and answer sessions. And please go to the Slido here and you can enter the code number TL0008 or just directly go to this link and treat everyone how you like to be treated and enjoy the guest lectures. Thank you. I'm Nadia from the Accounting Department of Airlangga, and I will serve as the moderator for today's guest lecture. Thank you, Theo. I think now is without further ado, the time is yours. Thank you.
Thank you, Nadia, and thank you, Laudi, for organizing this presentation. It will be my pleasure to share this work that I have done with the help of Professor Kennedy, my friend and colleague. I will start by sharing my screen. Okay. We are excited to have a chance to present this paper. It was just completed just a couple of weeks ago, so you are one of the first group to give us feedback. A couple of weeks ago, we gave a presentation at a seminar at Rutgers University, but we are really looking forward to your comments and suggestions. At any time during the presentation, if you have any questions, if you want to ask me something, please feel free to interrupt me. There is no problem. We don't have to wait for the end. I'll be happy to answer any questions you ask at the end of the presentations if you want to. I would like to start by providing the motivation behind the writing of this paper. And the motivation came from two papers. The first one is a paper by Vern Richardson and Marsha Watson that was published in Accounting Horizons in 2020. And in this paper, Vern and Marsha, they're saying that we need to do something about our accounting curriculum. We need to do something about accounting curriculum because there are so many changes that has taken place and they have been introduced because of technological changes. And more specifically, they're talking about the growth of data analytics and especially the growth of AI-enabled data analytics. And they say that if we don't change our curriculum, our students will be replaced. And if our students were replaced, we don't have a job. So it is kind of a wake-up call for the accounting community in the sense that we need to think seriously about the way that we are teaching accounting. The main message that comes from their story is that we need to revolutionize our accounting curriculum by infusing, by enabling the use of emerging technologies and data analytics. The second paper that kind of motivates our work is a paper that I wrote a few years ago with three, they were Ph.D. students at the time, now they're faculty, all three of them. And the objective of the paper that was published in GIS in 2017 was to kind of start a conversation. When we're talking about big data analytics, is this an opportunity or a threat to the accounting profession? And through the analysis and the argument that we're building in this paper is that it depends. It depends on what we're doing. If we don't make any changes, then it's going to be a threat. Because as Richardson and Watson suggested, our students will be replaced. On the other hand, and the main point that we're making in this paper, in the GIS paper, is that it is an opportunity because by the very nature of our training, accounting professionals, they're familiar with data. They've been working with data. Accounting you cannot conceive accounting without data. We're working with data. So the point that we're making is that there is the foundation. And if we build on this kind of foundation, we can convert this into an opportunity. We can position our students to take advantage of this growing market and a growing opportunity. So, given this kind of motivation, then we're going now to the objective of the paper that Dwayne and I have written on how to implement an data analytics and emerging technology enabled accounting curriculum. And what we're going to share with you is our experience. We're going to describe to you in the next few slides the curriculum that we have developed in Waterloo. And it is a data analytics and emerging technologies enabled accounting curriculum. As I will keep repeating, and we keep saying all the time, our job is not to replace accounting, because we are in the School of Accounting and Finance. The core competency of our students is and remains accounting. What we want to do is that we want to enhance the experience and the capabilities and the skill set of our students so they can thrive in a world of data and emerging technologies. So the objective of the paper is to share with you the roadmap, that the implementation plan that we use in Waterloo. The idea and the data, the Waterloo model of data analytics and emerging technologies was conceived as part of the school strategy. Around 2016, 2017, a committee was said, the SAF strategy committee was established. And the objective of this committee was to think about what's going to be the strategic plan for the school. The strategy committee met with people from the industry, met with our alumni, met with people from all different areas, consultants, high-level managers, mid-level managers, entry-level accountants. We met with all different types of groups. And the message that we kept getting from this kind of focus groups was that technology and analytics is an integral part. And it is important that we need to make sure that our students who are going to develop financial leaders who are fluent in the language of business, analytics, and technology. In other words, we want our students, when they enter the job market, to feel confident working with data, feel confident talking about emerging technologies, because this kind of confidence, when combined with their solid accounting and finance knowledge, that's what makes them successful. That will help them succeed in their professional career. So having this kind of strategic priority of having the goal that we want to develop tech-savvy financial leaders, then we decided, all right, what do we need to do, to develop this kind of students? Okay, it's one thing to say that, yes, we want our students to be tech-savvy, but we need to take actions. We need to make changes in our curriculum. And the two changes that we introduced as part of the strategy was that we want all of our students to have a strong foundation, regardless of what your specialization, whether you want to become a tax accountant, a financial accountant, a managerial, it doesn't matter. You need to have a good data analytics and technology foundation. So the first objective was to decide what's going to be this kind of foundation. The second one was to design specialization for the students who want to go above and beyond, who want to specialize in data analytics and emerging technologies. The rest of my presentation will be on the first part. When I'm talking about the data analytics and emerging technology enabled accounting curriculum, what I'm going to describe are the courses and the changes that we're implementing in the first and second year of our curriculum. Okay, so let's look at we started with the vision at the high level, what we want our graduating student. Now I'm bringing it a little bit closer to the ground. Now we have a vision for the students that finish their second year. In other words, by the time you finish your second year, what do we want you to know? And this became the foundation, what we call the data analytics and emerging technology foundation component of our curriculum. All right? We want them, students, by the time that they're done with the second year, to be able to handle entry-level jobs in accounting analytics. Okay? And a question that you may want to ask at this point is, Theo, what's so special about the second year? Why did you guys concentrate on the second year in particular? Why didn't you pick third year? The reason that we picked second year, because Waterloo is known as a cooperative school, which means by the time our undergraduate students are done with their 4-year degree, they have completed 3 work terms. When I'm talking about 3 work terms, I'm talking about 3 semesters when they're not in class. They're working full-time with a company. Okay? All of our accounting students have this kind of 3 work terms experience. And guess what? They start interviewing for their first work experience. We call the first co-op term in second year. That's the first time that they are going to a job interview. It's not their job interview for the final job, it's the first co-op term interview. So we want to make sure that students, when they go and start talking to the hiring managers who's going to hire them for the work semester, they can impress them. They can talk about data analytics. They can start talking about where they can contribute. Okay, so you see now what the justification behind selecting the second year as kind of the threshold. And we want all of our students to have this absolute minimum level of training. Okay, so now that you know what was kind of the objective, the vision at the high level for our graduates, we know what's our vision for our second year student. Let's move on now and start thinking about what kind of learning objectives do we need to establish if we want to make sure that second year students can step into an interview and convince the hiring manager that they are capable to handle entry-level data analytics jobs. All right? So these are the 5 learning objectives that we established. We want to make sure that they understand relational databases. They understand what it means that the data of the company is likely stored in a relational database. And if you understand that the data is in a relational database, which means there are multiple files that you need to combine in order to extract the data you need and perform your analysis, you need to understand SQL. So this was kind of one of the learning objectives. Understand relational databases, understand SQL. And the reason we established this because, as I was saying, when we were talking to our stakeholders, people who hire students, our alumni, they say that that's what we do most of the time. We're running queries. We extract data, manipulate data. So this has been important. Students should be able to run queries, perform the basic analysis. Now, once you have extracted the data, then the next objective is that you should be able to perform descriptive analytics. So, performing descriptive statistics, it's a requirement. You should be able to understand the foundational statistics knowledge which is needed to describe your data, describe the distribution of your data and what it means. Another area where we received feedback, as I was saying, from our stakeholders and from my own experience, consulting work that I have done for companies, for accounting firms. An area that's important for them is that you need to make predictions. Accountants need to generate estimates. So the average second-year student should have a good basic understanding of what it means to generate estimates. It doesn't have to be a very sophisticated model, but simple regression models, simple leveraging probabilities. Students should be able to do it, to generate estimates because they use them all the time. The fourth objective was that we want them to feel comfortable with emerging technologies. And there are technologies which are now entering, and like they are sort of the cutting edge, but there are also technologies which are mainstream. So we want them to be familiar. We don't want you to become an expert in blockchain, but you should know what blockchain means. If you're graduating, if you are a tech-savvy financial professional, and at the same time, you should be able to start leveraging technologies like RPA. Last but not least, we want, by the end of the second year, our students to feel comfortable communicating their analysis. Because if you are not capable to communicate your analysis, you have wasted your time. You need to convince your manager, your client, your stakeholder, whoever is going to make a decision based on your analysis. Explain what you have done. Your manager, your client does not have to be an expert in R or Python or any kind of statistical analysis in order to understand what you have done. You need to be able to simplify, communicate in single terms. So these are the objectives. That's what we want our second year student to be able to achieve, all right? So do you have any questions? Do you want me to continue? How are we doing?
You can continue with your presentation, and then we will discuss in the last sessions after your presentation.
Sure, thank you, Nadia. So now that you know what are the learning objectives, here are the 5 courses that all students, all accounting and finance students must take by the end of their second year. These are required courses, these are not electives. If you want to be an accounting and finance student, you must take these courses. You don't have an option. You don't say that, oh, I don't care about data analytics, I don't want to take these courses. If you want to be an accounting or finance major in Waterloo, you must take these courses. You must complete these courses in the first and second year. And the very first course, the Business Analytics 1, is a course that we offer in the fall of the first year. So when students in the very first term in Waterloo, they have to take the course from spreadsheets to R. In the second term, which is in the winter, they have to take the introduction to statistics. When they come back in the fall of the second year, they have to take the Business Analytics 3, communication using dashboards and storytelling. When they are in the second term of their second year, they need to take the remaining 2 courses. Okay? So what I'm going to do next is that in the next few minutes, I will explain briefly the content of each one of these courses. In other words, what we're trying to achieve. Okay? This is the first one, Business Analytics 1, and the subtitle for this course is From Spreadsheets to R. For those of you who have read the paper by Richardson and Watson in Accounting Horizons, they have established a set of criteria, objectives that a data analytics accounting curriculum should meet. And one of the first things that they say is that don't teach your students just keystrokes. Teach them a systematic process. Teach them to approach data analytics, accounting analytics, finance analytics, whatever you want to call it, in a systematic way. So we looked back when we're at the stage of developing this course and to find out what is the sort of the gold standard of the business, of the process for data mining. And we found out that there is a process that's called CRISP-DM, Cross-Industry Standard Process for Data Mining. And the Cross-Industry Standard Process in data mining says that whenever you're dealing from the simplest to the most complicated data analytics problem, here are the steps that you need to follow. First, you need to define the problem. Once you define your problem, you need to see what kind of data you have and to understand them. If after you understand data, you may want to go back and refine the business problem, then you're going to move into the stage of preparing your data. After you have prepared the data, you're going to do the modeling. After you do the model, you're going to evaluate the model. And after you have evaluated the model, you're going to go back to the business understanding and deployment. And of course, you need to communicate what you have found. So the way we designed this first course, every chapter, every week, every case we cover hits this 5 points in CRISP-DM. We start always with the business problem. We understand the data, prepare the data, create a model, evaluate, communicate. I typically, when I teach my class, model and evaluation, I combine them as one step, and communication I consider as my last step. So by the end of the first term, students have seen our terms are 12 weeks. For 12 weeks, they have seen about 10 different cases, and each one of these cases have been approached through this systematic process. Okay, so they have been used to the idea. They start becoming kind of second nature, the systematic approach to data analytics. The second objective of this course is, since this is their first experience with data analytics, is to give them a glimpse of different types of analytics. So we have a chapter, one of the first chapters, talking about data management. And we start with data management because you cannot do data analytics unless you have understand how your data is structured. So the very first case that we're doing is a case on data management. Then we have a simple case on descriptive analytics. Just show them how you can generate descriptive statistics. And based on the descriptive statistics, understand how a company is doing. Okay? Then we have a case on diagnostic analytics. And we present diagnostic analytics through pivot tables. When you're doing pivot tables, you're trying to understand, why is my performance not good as it was before? Why? That's diagnostic analytics. And then we have a very simple scenario where students can use probabilities to make predictions. If you leverage conditional probabilities, basically you're making predictions. Given this, what's the probability of something happening? And then we have a scenario with prescriptive analytics where the predictions you have made, combine them into a model now so you can make a decision. I will go into more details about the first course because this is one of the courses that has been completed, so I can share the details about this course. The last objective of this first course is create interactive dashboards. And we want students to learn to create interactive dashboards because it's an example of how you communicate your key findings. All right? So this is the first course, fall of the first year. All first year students must take this class. Okay? In the winter term, when they come back, they have to take the second course, which is an introduction to statistics. Okay? Now I need to clarify something. The course that I described, the first one, is completed, has been delivered in full scale the way I described it. The statistics course, we're still experimenting. We've made, for the last few years, we keep making changes. And what I'm showing you now is where we want to take the course when it's finalized. It's not there yet, but that's our goal. So what we're thinking and the motivation behind the objective on how we want ultimately to teach statistics, hopefully we're going to have the implementation. Myself and Dwayne, we're going to work on this to have the full implementation by 2024, is that we want to reimagine statistics. And we want to reimagine statistics for two reasons. The first one is, what's the point of spending half of the term teaching them how to do hypothesis testing based on a sample if I have the entire population? What do I teach my students? That you take a sample and you test the sample to see how the population behaves if I already have the entire population in my hands? We need to change this. And the second sort of motivation on why we are kind of redesigning the way we teach statistics is that it is very easy to teach someone a more machine learning. I can show you literally, for someone who understands just the basics of programming with R or Python, how to run a machine learning model with Python or R. And the simplest way of showing a machine learning model is regression. And regression is so simple, so intuitive. I'm like, when I saw a graph that shows a scatter plot that shows points that they go in an upward trend or downward trend, everybody immediately start thinking, oh, there seems to be a line there. And what I tell my students is that you have already performed machine learning in your mind. You have already implemented a regression model in your mind. So if it is so simple to explain regression, and regression is a form of machine learning, then why not redesign our statistics class to start with regression? Simple regression, like just show them quantity and price, estimate the demand curve. That's the simplest example that we're using to show our students. Once they understand regression and simple model with just one variable, then you introduce them to hypothesis testing as a way of testing, is the slope statistically significant or not? Because even though I have all the data, all my sales data, this is not, I don't know what will happen if I use the same model next year. All right, so now hypothesis testing makes sense. And that's the direction that we want to move. They understand why we want to use confidence interval. We want to use confidence interval because you can make a prediction now. You can predict what's going to be the quantity demanded for a given price. And you're not going to generate just a single point. You're going to estimate the range. All right. So that's what we actually were stealing the title from a book that was written by Hasty and Trevisan, if I remember the name correctly, when they're talking about statistics for the computer age. All right. And what we would like to do is that we're going to close this course, the introduction to statistics, by introducing conditional probabilities. Talk about Bayes. Why? Because if they understand conditional probability and can understand logistic regression, guess what? Now we're giving them a second example of machine learning. Okay? First year students. We don't expect them that they will go and build machine learning models, but they can sit in a conversation where someone is talking about machine learning and understand what's going on. That's statistics for our century, for a data analytics and emerging technology type of world. All right? The third course that they have to take is the one about communication, dashboards, and storytelling. This is a course that they take in the fall of the second year. This is only 6 weeks, half term. And if you remember, the first course that they took in the fall of the first year ended with the creation of the dashboards. It was a dashboard that was created using Excel. Now we bring them back and we ask them, no, create a dashboard now using either Tableau or Power BI. Okay? So they spent half a term learning how to sell the analysis that they've done. communicating the analysis that they've done. Okay, again, this course, which is still at the experimental stage, we have done it a couple of years using Tableau. We want to experiment next year with Power BI. It has not been finalized yet. The objective is clear. We know what we want. Simply, we have not finalized what's the final content because we're still, and to be honest, all of our 5 courses are in a state of flux. We don't consider anything as static. Even the courses which are completed, we keep changing because as new developments are coming up, we want our courses to become dynamic and change with the technology and the most recent developments. Now, after the fall of the second year, in the winter, our students, they're not coming back in class. They go and have their first work term. So from January until May, our students are not in class. They're working. They're working with accounting firms. They're working with companies in the accounting department. They do all kinds of jobs. So that's their chance now to have some real experience, real world experience. So when they come back now, they have taken the 3 courses that we have given, but now it's a great opportunity for us. Sorry, I think I skipped a step. To go back now and show them a course that has accounting and finance applications. So this is the 4th course now that they take in the summer of the second year, because in order to catch up, they have to take a course in the summer. Otherwise, they will not be able to complete their degree in 4 years. And the course is divided into 2 parts. The first part is teaching them SQL and relational databases. The second half is about forecasting using regression and ARIMA models. And the entire course is a series of cases. There's a case in financial accounting, a case in managerial accounting, and a case in tax, audit, finance. So they get a glimpse that accounting, data analytics can be used across the curriculum. That was one of the second objectives that was established by Richardson and Watson. They were saying that if you're going to revolutionize your curriculum, you need to make sure that data analytics is used across all curriculum, not in just one class. Okay, so that's the objective of this 4th class. At the same time, they take their 5th class. This course on emerging technologies in business. And the objective of this course is dual. First, we want them to understand why emerging technologies matter. Call this sort of the theoretical part of the course, in the sense that talk about new business models that have been introduced as a result of emerging technologies. You need to understand what's the effect that blockchain may have in the accounting profession or in business. You need to understand the effect of 5G, of Internet of Things, quantum computing. What kind of new business models have as a result of social networks and the internet? Okay, so this is kind of the theoretical part of the course. And then the practical part of the course is we need to make sure they understand and they can use some of these technologies. So what we have, and again, this is kind of one of the course we are still experimenting. 1 year we're experimenting teaching them blockchain, how blockchain works. Another year we used the RPA. And with the RPA, we chose it because it's an example of a technology which is used a lot by accounting firms. And it is a nice application in the sense that it shows students how I can go and automate some of my work now. There's no need to do things manually. So it's a nice way for them to see the use of an emerging technology. All right? So remember, these are the 5 courses that all accounting students must take by the end of their 2nd year. Okay? Where are we? I mentioned before that for one of these courses, I will provide you a little bit more detail. The course, the very first course that you're seeing in front of you right now, is the course that I've been teaching, and it is completed. The notes, teaching notes, are available for this course. If anybody is interested, I can provide you the hyperlink to go and download the notes. So I will tell you what I'm doing in this kind of course. Remember, it is the course that we're teaching to first-year students, fall, when they arrive in their first year. The course is, as I mentioned before, the objective is dual. First, we want to make sure they understand the CRISP DM process. The second one is that we want them to understand the different types of analytics. From a practical standpoint, we want our students to be able to use some tools. So what is the tool which is used a lot in the industry? Excel. So we spend the first half of the course teaching business analytics with spreadsheets. And I'm not using the word Excel because we don't have to worry about, oh, I have a Mac, I have a PC, my Excel looks different than yours. We teach them using Google Sheets. And what we tell them is that it doesn't matter. If you understand how it works with Google Sheets, you can move to your Mac, you can move to your PC, and continue doing it in Excel. We just, to avoid wasting our time, spending time trying to troubleshoot, oh, mine looks different than yours, we can simply use Google Sheets because it's common. That's the only reason. It doesn't mean that you have to use Google Sheets, because most of the companies, they don't use Google Sheets, they use Excel. So we spend the first half of the course teaching them the chapter about data management, where you understand how you organize and prepare data. And we show them what it means to organize data in a spreadsheet, how you start creating variables, if statements, formulas, this kind of thing. And then we have a chapter, once they understand this, we'll give them a data set and a company where the objective is to see the big picture. In other words, do descriptive analytics. And we're talking about the mean, the standard deviation, quartiles, etc., outliers. Okay? Sorry, I need to drink some water. And at this point, we can move to the third chapter, which is diagnostic analytics, where we introduce pivot tables. But we introduce pivot tables not as a keystroke, not click this and click that. Introduce pivot tables as a SQL query, because that's what pivot table is. When you're pivoting your data, you are running a SQL query. So all of the teaching, even though we're teaching spreadsheets, we're teaching spreadsheets as if it was a database. We treat spreadsheet as a database that has a single file. The second half of the course now, we're having a case with predictive analytics and prescriptive analytics. For predictive analytics, we have the data from OkCupid, a dating website. So we can talk to them about ethical issues. Is it ethical for us to analyze this kind of data? And the data set, which is based on surveys, has a lot of missing values. What do you do when you have missing values? It's a great opportunity for us to introduce probability theory at this point, and so how you can leverage conditional probabilities to generate estimates about missing data. So the idea of estimates and forecasting introduced by using simple tools like conditional probability. And then we have a course on prescriptive analytics, which is pet adoption. We have data from Kruggel about the pet adoption, and we created a scenario that you're a manager of a shelter, and there was a hurricane. We have a lot of pets that they are looking to be adopted. We're going to bring them. The manager of the shelter wants to bring them there, but wants to estimate what percentage of these pets are likely to be adopted within the first month, because I want to make sure that I don't bring more pets than what I can house in my shelter. So you see now a very simple scenario that they like, because I'm generating predictions, what I've learned in predictive analytics, but the predictions that I make become inputs into a model that I have created in Excel to estimate how many pets I need to bring in my shelter given my capacity. So it becomes a managerial accounting case. All right? And I forgot to mention that the second half is in R, because the data sets are more than 1 million lines, so they cannot use them in Excel. Part 3 now, we want to, one of the objectives, what we call ambidexterity. We want to make sure students can go back and forth between different tools. So we asked them to create an interactive dashboard, and the interactive dashboard is done in Excel. But the data set is so big, I'm using the Bibitor data, which says over 12.5 million lines, and you cannot do it in Excel. So first you need to analyze it in R, export the results in Excel, create your dashboard using Excel. So that's the example of the course, and if anybody is interested and wants to download a copy of the teaching notes, they are available. They can download from SSRN. The title of the notes is a first-year data analytics course for accounting students. Okay, so you can go ahead and download it from there. Different scenarios. People are saying that, what if we cannot implement all these 5 courses you mentioned? What should we do? You notice that accounting information system has been added at the bottom here, because for most accounting programs, AIS class is required. So we didn't even include it as part of the foundation because it was already there. And this is a course when you're talking about internal controls and these kind of things. So, a light version that we recommend, if you don't have enough room into your curriculum, just introduce the Data Analytics 1 and Statistics and the AIS. If you have more room, consider this kind of sequence. This is the sequence that all accounting students have to take in Waterloo. They have to complete these 5 courses up to the 2nd year. They have to take the 6th course in the fall of their 3rd year. Okay? Some of the challenges that we had as we're developing this kind of curriculum. One of the first one was that, how do we choose? How do we define the learning objectives, what we need to cover in the courses, etc.? And the answer for us, everything was driven by our strategy. First, we develop our strategy, and once we defined our objective that we want to have tech-savvy financial leaders, then we went back and looked, what does it take to achieve this kind of tech financial leaders? And came back with a foundational model, the 5 courses that I have described. So everything is driven by our strategy. And our strategy was based on discussions that we had with our alumni, with employers, everybody, stakeholders, everybody that we could talk to. I have to clarify something. We didn't ask the opinion of our first and second year students because we didn't think that there was a lot of input from them. We asked the feedback from upper year students who had already completed 2 or 3 co-op terms. Yes, we asked their opinion. But for the most part, we relied on our alumni, students who have graduated 1, 2 years, students who have graduated 5 years, students who have graduated 15, 20 years before, from the entire spectrum of experiences. The second constraint is that how do you add 5 new courses in a curriculum which is already jam-packed with courses? I'm sorry. I'm not used to talk non-stop for such a long time. I'm losing my voice.
It's fine, Theo. Take your time. No worries.
So we had to make a couple of sort of choices, trade-offs in order to implement our model. The first one, Waterloo is known for the engineering program. And in the engineering program, the first 2 years, students have no room for electives. So that was one of the choices that we made. For the first and second year, we make a model which is similar to the engineering model. During the first 2 years, students have room for only 1 elective. The other thing that we did was redesigning existing courses. For example, the course that we teach now, the data analytics one, replaced a math class. But when we're redesigning this class, we took elements from the math class and we introduced them as part of the new course. So in the new course, there is a strong emphasis on the algorithmic side of data analytics. We spend a lot of time, instead of teaching keystrokes, focus on why are you doing this? What's the logic? Why do you write this formula? Can you translate this spreadsheet formula into a math formula for me? Typically what we say is that, tell me what's the problem you're trying to solve. Describe the solution that you're going to make in English, not in a spreadsheet formula. You need to tell me in English what you're going to do. Once you have done this, I want you to convert this into a math formula. After you've done a math formula, now you want to implement it in Excel or R. So this is kind of the way of compensating for the fact that you had eliminated the math class. The other constraint that we're facing is that the faculty. I'm like, how do we find people to teach these classes? And one of the approach that we are implementing is that we try to find people within our faculty who are willing to retrain, retool. For example, the course that I developed, the one I'm teaching in the fall, I developed with my colleague Nancy Vandenbos. Nancy is teaching managerial accounting. Nancy came up with the cases, I did the analytics part. Together, we developed the class. Twain is teaching financial accounting, but Twain is old like me. When he did his PhD, he did his PhD on bankruptcy prediction models. Machine learning, that's what they're doing. So I went to Dwayne and told him, Dwayne, I need your help. And we're working together with Dwayne in developing, redesigning the statistics class that I'm describing. Why? Because Dwayne has the know-how. He can break it down. If he used machine learning, I'm not going to say how many years ago. Okay, Dwayne, we're not going to reveal our age. He can pass this knowledge to first-year students. So look within your faculty, look for people who have the some kind of related knowledge. The most important is that you need people who are willing to help. I've done the same with faculty from audit, tax, managerial. I'm like, just try to bring together people in order to develop this kind of material. Come to the end of my presentation, and we call this an eye in the future, or the 5-year challenge. Yogi Berra was a famous baseball player, famous for his quotes, and his quotes are hilarious. One of my favorite ones is that it's difficult to make predictions, especially about the future. Very wise statement by Yogi. And why do I like this statement, and what do I mean when I'm talking about the 5-year challenge? The 5-year challenge, and this is something that my friend Nancy introduced when we're as part of the strategy committee. Nancy told us that you realize something, that if we implement a new curriculum today, in other words, these kids who are going to be in my class in the fall, they're not going to be in the market until 5 years later. So when we redesign, when we are developing a data analytics enabled accounting curriculum, our target is not for today. Our target is 5 years in the future. So that's what I meant when I said that the courses are dynamic. The first course is completed and the fourth one is completed, but even completed courses keep changing. We keep tweaking them every year because we have new things coming up. And I'll just give you a few quotes from to appreciate this. That was from an interview published in the Wall Street Journal. I think it was in the springtime, I forget when was the exact time. Interview with the Google finance head, and talking about projecting how machine learning is used to generate predictions. And they are more accurate than analysts developed forecast. Which means that an accounting student who knows machine learning does not need to rely on a data scientist. They can develop their own forecast if they know how to use this kind of tools. A similar quote from Microsoft. Again, we're talking about how important forecasting is for Microsoft. And they are talking about how their finance team has remained flat while Microsoft keeps growing. They don't need to hire more because they are automating a lot of their tasks. You realize now why RPA is important, because existing professionals can do more with less effort. They can concentrate on the part that adds value. That's why we need tech-savvy financial leaders. The last one is from a paper by Ph.D. and all. It's a recent one. And the paper is talking about how AI has entered audit. And the message that they are getting here is that entry-level jobs are replaced. Okay, so you realize now that we want our second-year students to be able to handle entry-level jobs, because by the time they graduate, the job that they did as co-op, the entry-level job, may have disappeared. Okay, so that's all. I have already shared. I'm like, if anybody is interested in the paper, is available on SSRN. If anybody wants the slides for this presentation, I'll be happy to give you the link. Maybe I can do it right now as we are getting ready to for the questions. So I will go into the chat and I will post the link to my slides. So if you want my slides, go ahead, you can download them from this link. Okay, Nadia.
Thank you very much, Theo, for your very insightful presentation. I think this is like the need for our accounting department to enhance our curriculum, especially incorporate the technology part. And then there are several questions already from the audience. But before that, I want to ask you, how long have you been implementing this curriculum, Theo, in Waterloo?
We started in 2017, and we keep we're experimenting. This module, this what we call the Waterloo model of data analytics and emerging technology, was not developed overnight. We're experimenting a lot with our classes. For example, the very first year when we're thinking, we tried, instead of introducing a separate class, the one that we have in the fall, basically have the two classes combined in the introduction to statistics. Students rebelled. You realize it was too much, it was too difficult, they could not handle it. So we keep doing this kind of experiments, and we try new things, and you have to continue trying new things.
Yes.
And what I'm presenting right now, it's based on experience of the last 5 years.
Okay, and you said that this is for the next 5 years, right? This curriculum.
Yeah, the goal is that to have a curriculum that's going to be relevant.
Yeah.
For the next 5 years too. Yeah.
Okay, thank you very much, Theo. Would you mind to stop your screen, please? I would like to share the questions from the audience so that you can read it more clearly, maybe.
Sure.
Okay. Here are the questions. Okay, the first question is that how did you come up with the sequence of skills being taught to students? I guess there should be some kind of justification regarding the sequence.
Yes, it's a very good question. And the answer for this one is based on the setup that we have for the course that we teach in the first year. If you remember, the way that the sequence of the courses that I'm teaching in the fall is starting with something simple. From a skills standpoint, we start with spreadsheets because it is simple. Everybody can use Excel. And once we have introduced Excel, then we can transition to R, and we can transition to R because of necessity. In other words, when they feel comfortable doing pivot table analysis with a data set that has about, let's say, 10,000 lines, then when they come back in the second half of the course, I tell them that, can you do pivot table analysis of the data set that has 12 million lines? And they're saying that, oh, I get an error message. All right, now you realize now why we need to transition to R. Okay? This is kind of the justification on why we go from spreadsheets to R. The question may be, why do you pick R and you didn't pick something like Python? The reason we pick R is because we want to keep it simple. And R is simpler than Python. Typically, students who ask, oh, can we use Python? I tell them, you can figure it out on your own. If you know R, transition to Python, it's going to be very easy. Another question that was asked is that, why don't we go use Power BI? Why do we use R? And the answer that we have here is that I don't know in 5 years from now whether Power BI will be still popular, but I promise you R and Python programming languages will be still relevant. And if you understand R or Python, you can transition to Power BI. It's going to be much more difficult to transition from Power BI to Python or R.
Mhm.
The other choice that we're making when we're talking about sequence of skills is that we don't see it as a sequence of skills. We use the term ambidexterity, which means that I should be able to use both my hands. I should know when it is appropriate to use Excel and when it makes sense to transition to R or transition to Tableau. If I learn only Excel, then I'm trying to solve all my problems with Excel, which not be the best approach. So ambidexterity is important for us. We want students, so you realize by the time they're done with the 2-year sequence, they have already seen Excel, they've seen R, and they've seen either Power BI or Tableau or both of them. Because a scenario that we're considering is that switch to Power BI in the second year and add Tableau as part of the predictive analytics class, because you create nice visualization when you're to show your model.
Okay, thank you, Theo. And for the second questions, how do you get adequate support from the university regarding the resources required? Is there any resistance from the university?
You realize that we developed our strategy first. Our faculty voted on the strategy. They agreed that this was an important objective. Once we had established that this was an important objective, we told them that, look, if we want to reach this objective, we need to implement this curriculum. And we need resources. It's still an uphill battle. I'm like, we're not able to hire as many faculty as we wanted. I'm like, this year I was very upset with the people in the hiring committee because they had promised me that I will be able to hire one more person to help me, but I was sidestepped. Yes, we have this kind of thing. This is normal. In any university, you're going to have this kind of battles. But the most important thing is that our choices are driven by strategy. We don't say that, oh, it would be nice to have this. We have a strategy, and what we are trying to implement, it was part of our strategy. We voted on this strategy, so nobody will come back now and say that, oh, why do we do this? You agreed that we need to implement this.
Okay, thank you. And then for the next questions, there are human aspects regarding the implementation of new technology. How do you incorporate the human aspects in the development of the curriculum?
Do you mind giving me an example of what you have in mind, just to make sure that I give you the right answer to your question?
Okay, maybe who asked these questions, can you turn on your mic, please? About the human aspect. Anyone here? Because there is no name for this question, so that I don't know who asked these questions.
I'm not sure. Like, are you talking about human aspect in terms of resources to implement the curriculum, or the human aspects of how students feel about dealing with technology in their curriculum? I have already mentioned the fact that, yeah, the resource constraint is there, and we're trying to be creative. I mentioned the example of how I'm working with Dwayne to reimagine the statistics class. And Dwayne was not, if you had seen him based on his experience, he was a financial accountant. He was not doing data analytics, but as long as you have someone who is willing, you can come up, you can find creative ways. I'm looking forward to the really reimagined statistics class, because I have faith. Dwayne has the training. he's the right person to deliver this. Now, if the question is in terms of human aspect of how students feel about technology, we try to introduce technology in small steps. And I'm talking about small steps in the sense that we start with Excel, because Excel is simpler. And the way that we're teaching our classes is that, I didn't mention this as part of the delivery, but the model that we're using is that my class has about close to 600 students. And I deliver the lecture via Zoom. And then I divide the class in groups of 30 to 35 students, and they go with a seminar leader and a TA, and in small groups they try to replicate the hands-on experience of the course. And then they come back in the second lecture that I do at the end of the week, again via Zoom. And the objective during the second lecture is to interpret what they've done in the seminar, apply. So the way we're trying to deal, if the human aspect is sort of the how students feel about technology, we're trying to deal this through the small group seminar setting.
Okay, thank you, Theo. This is the 4 questions. Does the curriculum go as expected and achieve the intended learning outcome? Did you make any adjustment?
Let me start with the last one. Yes, we constantly make adjustments. And we refine. One of the adjustments that we're making is, as I mentioned, I think that I mentioned this before, in the second year class, when we're talking about the visualizations, we started with Tableau, but now we're thinking to switch to Power BI because more and more of our employers are using Power. They told us that they prefer to use Power BI.
Oh, I see.
Whether it met the intended learning objectives, the feedback that we have from our students has been positive. They like the idea that they know they can talk about data analytics, they can use data analytics. But the best proof whether we're achieving our learning objectives comes from the fact that we have second year students who go and do their first co-op term, the first full-time term, and they're hired to do data analytics jobs. For us, that's the best proof.
Nice. Okay, and then we still have more questions. Today we have many questions. I believe the study would get more insights if it is complemented by an expert study regarding the content of the curriculum, the sequence, and so on. I think this opinion from the audience still, this one, about expert study that incorporate the content of the curriculum. And then
there, you'll have to give us a little bit more feedback because I have to admit that I'm not doing design study or experiments, so I'm not sure how to do it. And same with Dwayne. Dwayne, do you have any experience with expert studies?
No, that's not my area of expertise.
Yeah,
I've been working generally on empirical research studies.
Same with me. Can the person who wants ask the question give us a little bit more feedback on this one?
Okay, who asked or who shared this opinion, please, can you explain to us about the expert study? Anyone here from the audience? Okay, hello. Okay, Theo, maybe can be
okay.
He or she is not here. Yeah, okay, or because there is no name again for this question, sorry. And then for the next questions, this is from one of our lecturers here, because it's very difficult to insert new course, especially for our curriculum here in Indonesia and especially in our department. How about we add only 2 courses about basic SQL programming and business analytics at the accounting curriculum?
You will need to decide. I'm like when I remember when I was showing you the table with the different options that you can consider. It depends what you are including.
Oh.
In other words, you cannot go straight into, I'm like, a SQL without talking about databases cannot be understood. This is the reason when I'm presenting the first course of the data analytics, when I'm saying that I'm presenting pivot table as a SQL code, I have already started by introducing the idea that a spreadsheet is a database. It's a database that has a single file, and then I go back and introduce SQL. But where SQL really earns its money is when you switch to relational database. So this is something that we do in the second year. The other thing which is important here is that I'm assuming that you have a course in statistics.
Yes,
because
you have statistics, but for hypothesis testing course.
Yeah, you cannot talk about business analytics without statistics. Yeah.
Okay. Thank you, Theo. And then the next question is, how do you anticipate possible changes along the way in the curriculum development and implementation?
My research is on emerging technologies, emerging technology adoption, and like you posted some of my papers. So I'm part of the AIS community of the AAA. I'm attending the meetings, and always talking to other people. People in the industry will give you a lot of feedback in terms of what they are using. And like a lot of cool ideas come from other schools, other departments, what they're implementing, or people in the industry, what they are using.
Okay, thank you. And then next question, how about the data analytics for master and PhD students?
That was kind of a conversation, especially for the master part. When we're developing the curriculum, Waterloo is known for being on the cutting edge of innovation. So the curriculum that we have for our undergraduate students is kind of the equivalent for a master's program, but we don't want to design a master programs in data analytics because our students take a master's in accounting, and we don't want to have just a master's in data analytics. For PhD students, I'm like, I don't talk about this because I'm not working with PhD students. In other words, I'm not part of the PhD program. I work with PhD students, but I work with PhD students to write papers. So I believe that students who reach the PhD level, they have already acquired the training in data analytics that they need in order to do their PhD.
Okay, thank you. And then the next questions, in what way do you think the full potential of the curriculum you described can be achieved?
We are in the process of hiring one person this summer in data analytics, and I'm hoping that we can hire one more in the spring or next summer, and possibly one or two more in the next couple of years. Once we have increased the foundation in terms of expertise, then we're going to have a curriculum that has reached its full potential. But keep in mind the point that I mentioned before. There is no such thing as full potential. It's not. Things are changing. What we're hoping is that build around the core skills, the core competence that we have defined. And once we have developed the core skills, refine by changing the tools that we're using. For example, like maybe in a few years from now, instead of using RPA, we'll maybe using intelligent process automation and some other tool. Right now, Automation Anywhere and Blue Prism are the tools used, but something else may come in the future that can replace them.
Okay, thank you, Theo. Let me check one more from the slide, maybe that there is more question or not. Yes, there is more question. Is it possible to involve practitioners to be part of the teaching team rather than rely entirely on the academic staff? I mean, the practitioners.
Could you repeat the question?
Okay, sorry. Is it possible to involve practitioners to be part of the teaching team rather than rely entirely on the academic staff, maybe from
absolutely,
from industry?
We have a lot of our alumni are helping us, are teaching classes. The important thing is that you need to have someone who is in charge of the course. You need to have someone who is responsible for the vision, the learning objectives, high-level content. And then you bring practitioners because they have experience and they can deliver this kind of courses or contribute. We have practitioners developing electives for us.
Okay.
Yes, it's a very good suggestion. Leverage your alumni as much as you can.
Okay, thank you, Theo. And then here, do you cooperate with other departments such as engineering, computer science, etc., to teach these courses?
The short answer is no. And the answer is no because the computer science program is too advanced for our students. The other reason that we don't cooperate is because we do not want to produce data scientists. We're producing accountants. We want to produce accountants who can leverage data analytics and emerging technologies. We don't want our students to become an expert in programming. Because remember, the 5 courses that I've described are required from all students. It will be unrealistic to expect that all accounting students will be able to take programming classes and be as proficient as students whose full-time training is in computer science. So this is one of the reasons why we decided to develop our own classes. The other reason is that the computer science program of Waterloo is extremely rigorous and extremely competitive. They have no room to develop new courses for us. We approached them and we asked them if they could help us, and they said that they don't have the capacity. And they didn't want to develop a service level course for us. And our experience with service level courses which are taught by other departments is that typically what they do is they find a PhD student who's going to deliver the class, and they have no vested interest in creating a course that will be geared to what we want. We want courses for our students. So this is the reason that at the same time, students who want to take electives, we encourage them to take courses from math and computer science department. But you realize that now we're talking about students who want to take an elective. Okay? They choose to take a course in computer science, and they understand that it's not going to be an easy course.
Okay, thank you, Theo. This is the last questions. How this new curriculum has an impact on how quickly accounting graduates find jobs?
You realize that our students, by the time they graduate, they have completed 3 terms of full-time job. Most of them, they already have the job before they graduate. When I'm talking about most of them, we're talking about 98% of the students. They already have a job before they graduate because they already have connection. Companies where they have worked for 3 terms typically hire them back. Dwayne, please correct me if I'm wrong in this kind of information.
No, you're correct, Theo, that the vast majority of our students already have positions arranged before they complete their degree by returning to some of their co-op employers. Typically the ones that don't have a position arranged are because they've decided to go on to grad school or something of that sort. So they pretty much have that. And in addition, having that work experience makes it very easy for the ones that choose to change employers to be able to get a position. So yeah, we're pretty close to 100% of our students are employed when they graduate or have chosen grad school.
Okay, thank you, Dwayne and Theo. Yeah, I think that's all. And Theo, because now we are still working on also data analytic courses for undergraduate students, is it okay if maybe I email you and discuss about these courses?
Absolutely.
Okay, thank you very much. Before we close, maybe you have some more closing remarks to the audience here.
It was really nice. I'm like, thank you for giving me the opportunity to present. I'm like, we had very nice questions. And the one message for that I have is that it's a moving target. Like, if you enter, you will need to keep training. I'm like, it's not something that you do and forget about this. I'm like, you will need to update your training if you want to stay relevant. At the same time, I'm like, if you're young and you're in the beginning of your career, make sure you leverage analytics. Make sure you incorporate, make data analytics as part of your training. I'm like, this is something that one of the messages that we want to communicate with our students is that data analytics is equally important as your financial accounting, as your managerial, as your econ and business understanding. It's not something you say that, oh, I'm not interested, I'm not gonna. You need a foundation if you want to succeed, if you want to be a successful professional in this world.
Okay, thank you very much, Theo, for your great insight. And before that, maybe we will take a picture together with the audience here. Please,
Sure.
the audience, turn on your camera for a while. And the committee, anyone will help me to take a picture.
All right, ma'am. Maybe I can start from the first page. 3, 2, 1. Okay, I think that's all. Thank you.